Coming up on Destination Tomorrow, we take a look at NASA's Aviation Safety Program. We'll look back at some highlights of the program and find out what the future holds for aviation. All this and more next on Destination Tomorrow.
Hello everyone, I'm Steele McGonigal.
And I'm Kara O'Brien. Welcome to this edition of Destination Tomorrow.
On this episode, we'll be focusing on the pioneering work that has been completed by NASA's Aviation Safety Program.
Throughout NASA's long history, one area of constant focus has been in aircraft safety. From its predecessor agency, the National Advisory Committee for Aeronautics, until now, NASA's researchers have worked tirelessly to make flying safer for all of us. Today in the United States, over 600 million passengers fly safely every year, making flying the second safest form of mass travel in the world, with only elevator and escalator rides being safer.
But even with this incredible record, NASA personnel are constantly striving to make it even safer. With this in mind, a pioneering program called the Aviation Safety Program was developed in 1997 to help raise the level of safety to even greater heights. NASA planners, in cooperation with the FAA and the White House, formed this program to research and develop technologies that would significantly reduce aircraft accidents by the year 2007. This program has been enormously successful in researching and developing cutting-edge technologies to make flying safer. On this episode, we'll take a look back at some of the stories that we've previously featured on Destination Tomorrow, and we'll find out what's in store for the future.
Our first segment will look at the Single Aircraft Accident Prevention Program, or SAP. This program uses data available from aircraft and simulators to identify and correct aircraft system problems before they lead to fatal accidents. Here is the story as it first aired.
We've all heard that flying is the safest way to travel, and statistically it is. Even as our world's airspace becomes more crowded, flying today is actually becoming safer. But unfortunately, fatal aircraft accidents can still occur. That's why researchers in the Aviation Safety Program are working on revolutionary technologies that may make fatal aircraft accidents a thing of the past. The Single Aircraft Accident Prevention Project, or SAP, is part of the Aviation Safety Program that is developing new technologies that may help pilots recover and safely land an aircraft from a potentially fatal event. I spoke with John Foster in the Vehicle Dynamics branch at NASA Langley to find out more about SAP.
Well, the SAP project is developing systems that will anticipate failures on the airplane before they occur and help the pilot recover the airplane if an out-of-control event should occur.
What's an example of an out-of-control flight situation?
Well, there are a number of factors that can contribute to an airplane loss-of-control accident. These factors can be both internal or external to the airplane. Some external factors may include severe weather or just poor visibility. Some internal factors, though, could include some failure in the control system, as well as a structural failure or just an inappropriate crew input.
In many of these situations, catastrophic failures cause the pilots to lose control of the airplane, resulting in a fatal accident. Researchers in the SAP project are working on new technologies which they hope will prevent these types of accidents from ever occurring again. They are developing a series of revolutionary systems that will not only detect and predict system or component failures before they become severe, but are also developing automatic control recovery systems, which will actually help pilots recover an airplane from an upset situation. Okay, so how do these systems help a pilot out? I mean, how do they work?
Well, the Vehicle Health Management System is being developed, which will continuously monitor the airplane's health and compare that to the math model for a healthy airplane. In case a disturbing trend or an anomaly occurs, it can send that information to the ground crews and they can take the appropriate maintenance action to fix the part after the airplane lands.
Wow, kind of like an onboard doctor.
Exactly, that's why it's called health monitoring. Another system being developed as part of the SAP project is the control recovery system. This system is being designed to help the pilot in case the airplane gets into a loss of control situation. That system will carry a math model of a normal maneuvering airplane on board. And if the system detects that the airplane is about to enter a loss of control situation, it can alert the pilot and help him to recover the airplane, or it can automatically recover the airplane for the pilot.
These systems will not only be able to help a pilot regain control of an aircraft quickly, but will also be able to help land an aircraft that has suffered catastrophic damage. With these new systems on board commercial planes, pilots will be able to maintain safe flight even under the most adverse flight conditions, potentially making fatal crashes a thing of the past. Okay, so the systems you've mentioned are obviously computer systems, but we're standing here in a wind tunnel. How does wind tunnel testing help?
Well, wind tunnels are used to develop pilot training simulators. We can take the data out of the wind tunnel for extreme flight conditions and put that in the simulator and allow the pilot to experience an out-of-control event and conduct training to learn how to recover from such a situation. Our goal is to provide the most realistic training possible for the pilots in case they would enter a loss of control situation.
John, how will these systems be tested before being implemented on an airplane?
Well, there's several methods that we can use to test the systems before they are actually implemented in the airplane. One is to use a subscale, dynamically scaled flying model of the airplane. In that model, which is remotely controlled, we can install the actual systems in onboard computers and then fly the model through various out-of-control flight conditions and then see how the system works to recover the airplane.
What are your hopes for the future of this project? I mean, what are the future goals of SAP?
Well, flying is already a very safe form of transportation, but accidents still occur. And our goal in this research is to develop systems that will specifically help reduce those kind of accidents and save lives.
Coming up, we'll find out about a new computational tool that is being used to help analyze aircraft data. But first, did you know that NASA has developed a synthetic vision system that can help prevent aircraft accidents? The synthetic vision system incorporates a high-resolution display, GPS, and a detailed terrain database that shows outside terrain even in low-visibility situations. This outside view will help eliminate one of the deadliest forms of aircraft accidents, called controlled flight into terrain. It does this by displaying terrain obstructions on a clear, unambiguous, and easy-to-see display panel mounted in the cockpit. This system is currently being incorporated into military and business jets and is also being adapted for commercial flights. With this system active, controlled flight into terrain should be a thing of the past.
On any given day, roughly 87,000 planes are in the skies over the United States, with about 30,000 of those planes being operated by commercial carriers. With this number of flights, aviation experts work hard to make sure that all these aircraft are safe. To help ensure their safety, a new statistical and computational tool developed by NASA is being used to study the data from every flight. This tool, called the Morning Report, is compiling vital information and placing it into an easy-to-use database, catching potential problems before they lead to accidents. It works like this. Every commercial flight has computers on board that monitor systems. These computers record huge amounts of data looking for any anomaly. But due to the sheer number of flights every day, not all flight information was being monitored by ground crews in a timely fashion. To help change this trend, the Morning Report was developed to take information from every onboard computer in an airline fleet, then compile it into a detailed list which is supervised by aviation experts each morning. If anomalies are found, a safety analyst will look at the aircraft in question immediately. This early notice is allowing engineers to potentially catch problems that could lead to an accident. The Morning Report system is now being incorporated into many commercial airlines here in the United States.
Even with these new advancements to catch problems before they happen, we know that accidents can still occur. But when accidents do happen, the chance of surviving them has increased significantly in recent years. From 1983 to 2000, the National Transportation Safety Board investigated 26 major commercial accidents involving 2,739 people. A total of 1,525 of those people survived the accidents, or about 56%. Much of the reason for this increase in survivability is due to better design and crash testing. NASA has worked tirelessly to improve aircraft safety by developing key programs and facilities to research crashworthiness. One facility, called the Impact Dynamics Research Facility, or IDIRF, has been in the center of much of this research. We've spoke with researcher Lisa Jones about the IDIRF facilities in an earlier program to help us understand how the facility works.
Although most of us don't like to think about it, the thought of crashing creeps into almost every passenger's mind when boarding a plane. We all know that air travel is the safest form of transportation known to man. In fact, statistically, you'd have to fly once every day for more than 8,200 years before you'd be involved in a fatal aircraft accident. But tragically, we know that crashes do occur. Fortunately, NASA operates a unique facility called the Impact Dynamics Research Facility, or IDRF, to research and conduct crash testing of full-scale aircraft. The knowledge learned here is making air travel safer in the unlikely event of an accident. I spoke to Lisa Jones of the NASA Langley Research Center to find out about this one-of-a-kind facility.
Well, 80% of most accidents that occur now are survivable accidents, but we're working to bring that number even higher so that people who are involved in an accident that is classified as survivable walk away. But our main goals have to do with aircraft crashworthiness, testing them and improving them so they're safer to fly in. And the way we test these aircraft is we suspend it from the facility and allow it to swing like a pendulum into different surfaces. And we instrument the aircraft and put crash dummies on, and we collect the data during the test and look at it after the test, along with a lot of high-speed film and a lot of photographic information, and determine if real people will be injured or not. And then we also use the information to change structural things in the aircraft to improve how well it absorbs energy and takes it away from the occupants and prevents them from being injured. So that's basically crashworthiness, preventing the occupants from being injured in a crash. The facility was here already. It was the Lunar Excursion Module Simulator where they trained astronauts to land on the moon. Then in the 70s, there's a lot of aircraft accidents, small general aviation aircraft accidents. And we felt that it was time to do something about it. And so we actually recycled the facility so that we could lift these aircraft and crash test them.
The IDRF team set out to discover why crashes that should have been survivable were actually incurring fatalities. In the course of their testing, they found that most of the deaths caused in what should have been survivable air crashes were not due to fire injuries as you might expect, but were in fact due to load injuries. A load injury occurs when a brief but extreme amount of force is exerted on the body. During testing, researchers discovered that passengers were experiencing the full force of the impact of the plane during a crash, producing enormous, unsurvivable load forces on their bodies. This is very similar to crash data discovered by automobile makers. Car accidents of the past were much less survivable than crashes in recent years. This is because newer automobiles have been designed to absorb and dampen the majority of energy in a crash, keeping passengers safer. The researchers at IDRF began designing and implementing new dampening systems to be placed on board airplanes. New systems like energy-absorbing seats dissipate and absorb energy during a crash, greatly reducing the load weights being experienced by passengers. This single change has saved many lives.
We found that changing the seats has made a lot of difference and saved a lot of lives. However, there's more we can do. We need to look at the whole system, like changing the structure so that not only do we have the seats stay attached, but energy is taken out of the system through the structure itself. And they're wearing special restraints that keep them in their seat, and also may even put airbag technology in some of the aircraft. And for large airplanes, we're even looking at changing the design so that it will deliberately brake in certain places. Then we can determine where not to put hot things or sharp things or fuel lines and things like that so that people can get out or egress through these openings in the large aircraft.
Lisa, a lot of the things that you described are things that NASA and the industry are doing to make flying safer, but is there anything the general public can do to make flying safer?
Yes, you can check your luggage, all of it if possible, because things in the luggage bins do become flying objects in a crash event. Computers, for instance, are very heavy objects, and if they come flying through the aircraft at landing speeds of 200 knots, then you have an issue because it will definitely injure people. People are not replaceable, things are, so if you can check the luggage, then you're doing a great service to prevent injuries in an accident. We want people to walk away from these survivable events and not have any injuries, and we're working hard to get there.
Did you know that NASA researchers are working with industry to better train pilots and airline personnel? In recent years, NASA researchers have developed textbooks and web-based programs that help increase pilot proficiency in an automated cockpit, while also improving training for maintenance crews and inspectors. These programs are increasing awareness and helping to prevent future accidents from ever occurring. In recent years, NASA researchers have also been focused on reducing fuel flammability and in detecting fires aboard aircraft. In fact, NASA recently won the prestigious R&D 100 award for a fire detection system that has a very low false alarm rate. Dust, dirt, and aerosols frequently fool current fire detection systems, creating about 200 false alarms for every real fire. This is problematic for many different reasons. When a fire alarm goes off, a pilot will immediately initiate emergency landing procedures and will divert the flight to the closest airport. This is not only inconvenient, but is also very expensive, costing the airlines about $50,000 for each false alarm. It's clear to see that this new NASA system will not only save money, but also make flying safer.
NASA has also worked to reduce the chance of an explosion inside an aircraft's fuel tank. When some fuel tanks are not completely full, research has found that wiring inside the tank may cause sparking. This sparking could ignite the oxygen contained in the empty space, causing an explosion. To fix this problem, researchers have designed a fuel system that can replace the oxygen in empty spaces with nitrogen. This works well because nitrogen suppresses fire while oxygen feeds it. Coming up, we'll take a look at a unique facility that is designed to test aircraft icing. But first, did you know that even if the engines on a large commercial aircraft fail, it should be able to glide safely to the ground? Most commercial jet aircraft have approximately a 15-to-1 glide ratio, which means it will glide 15 feet for each foot it descends. At this rate, an airplane flying at 35,000 feet can glide for about 525,000 feet, or 100 miles.
Weather conditions play an important role in all flights. Perhaps one of the most dangerous conditions that can affect aircraft is ice. Fortunately, NASA researchers have been using a unique facility that can simulate the icing effects on aircraft.
Thanks for the ice. You know, there's nothing like a beverage chilled with ice during a long flight. Inside an airplane, ice is something passengers desire. However, outside an airplane, ice can be dangerous, especially if it forms on the wings or engines. I had the opportunity to speak with Judy Foss Van Zanti at the NASA Glenn Research Center in Cleveland, Ohio. She's researching the effects of icing on aircraft at a unique facility called the Icing Research Tunnel. Researchers at this facility study the formation of ice on the exterior of aircraft. So while flying, the only ice you'll need to worry about is the ice inside your cup.
Well, I'm standing right here in the Icing Research Tunnel. Right here we create on Earth what it's like for an airplane to fly through an icing cloud up there. To do that, we got to make it windy, cold, and wet. Now right now I'm standing in front of the fan. We have the fan to create the wind, and in the test section, which is a much smaller cross-sectional area, we can get winds up to 400 miles per hour. So that's about as fast as a plane might fly through in an icing environment. We create the cold with our heat exchanger, 1,700 ton. It can cool 500 homes. That's how big it is. We can get from 0 Celsius down to about -20, which is where the icing might occur in nature. And we have spray bars. The spray bars is what makes the icing tunnel. We create the rain. We create a mist that the airplane would fly through. Now the thing about the spray bars is the researchers need to control both how much water is in the cloud, the liquid water content we call it, and how big the drop size is. And we have spray bars specially designed to create those conditions. So in our test section, we create what it's like for a plane to fly through an icing cloud.
So why did NASA build an icing research tunnel?
As it turns out, during World War II, the Allies lost more aircraft to icing than enemy fires. They were trying to fly supplies over the Himalayas. So the Air Corps turned to NACA, that's NASA's predecessor, and asked them to build an icing research tunnel so we could understand what was going on and how to fix the problem.
So what do you test in the icing research tunnel, or the IRT?
What we test in the IRT is what makes sense to test. Now if you think about it, if you're in an airplane flying through an icing cloud, what surfaces are most critical to keep ice-free? Well, it's the wings, which provide the lift, get you off the ground, and it's the engine inlet, which provides the forward thrust. So we typically can test just those components, just the wing or the engine inlet.
So what happens when ice forms on an airplane's wing? Well, ice can disrupt the airflow over a wing and will eventually cause the airflow to separate. This separation of airflow creates more drag and less lift. If ice continues to form, the wing will no longer produce the appropriate amount of lift needed to keep the airplane in flight. In some cases, ice creates airflow separation over movable parts, like an aileron. This could create handling or control problems, and the plane could suddenly roll.
As the wing is flying through the air, the ice only accumulates around the leading edge. So that's why ice protection systems only wrap around the front part of the wing. The biggest factor in how the ice grows is temperature. So if it's really cold, the water droplet comes in, hits the front part of the wing, and freezes on impact. And you get this nice pointy rime shape. The more dangerous ice comes during warmer conditions, those closer to freezing, where the water comes in, hits the leading edge, and actually runs back a little bit. If that happens, the next droplet might come in, see that droplet that is frozen, and start to grow. So you might get these ram's horns that grow upstream. Now that significantly disrupts your airflow, and that's way off design, and that's very bad.
Judy, tell me a little bit more about the icing protection system. Do all planes have it?
There's what we call an anti-ice system, where you don't allow the ice to grow at all. That's if you got a very hot leading edge. You see that in jets. Then there's a de-icing system, which has pneumatic boots, that the boots will wrap around that leading edge, they'll inflate and pop the ice off. So you let the ice grow, and then you got to get it off. The pneumatic boots are typically what you see with turboprop aircraft.
Does icing affect planes in, say, a warm climate?
Icing occurs everywhere. You've got to be aware of it. I've got a pilot friend who told me the worst icing he encountered was flying from Florida to the Caribbean in July at 16,000 feet. The worst icing he ever saw. But icing really can occur anywhere and any time. One of the things we do here at NASA is to have better designs. So maybe a system that would automatically turn on the ice protection system if a sensor goes out. The short-term solution is to train the pilots and educate them about how to detect icing, how to be aware of it, train them how to get out of the icing environment if and when they need to. Ideally, icing is a non-issue in the future. We're working to get there.
For many of us, fear is the biggest problem when it comes to flying. We thought it may be helpful to present you with some statistics that may or may not be helpful to those of you who are fearful flyers.
First, your chances of being involved in an aircraft accident are approximately 1 in 11 million, while your chances of being killed in an automobile accident are about 1 in 5,000, proving that the most dangerous part of your flight is the drive to the airport.
One last fact. Statistically, you have more of a chance of dying from the food served on board the flight than being involved in an aircraft accident.
Most people who have flown in an airplane have experienced turbulence. NASA is working on new warning systems to help pilots avoid dangerous turbulence. Paula Vaden has more.
If you've ever flown in an airplane, you are probably familiar with turbulence. Even for the most experienced flyers, the sudden, sometimes violent, irregular air motion can be an unsettling experience. In most cases, turbulence is merely an inconvenience that passengers and flight crews must endure. But in cases of severe turbulence, the violent shaking can not only cause serious injury to passengers and crew, it can also be fatal. In an effort to help aircraft avoid turbulence, researchers at NASA are testing new onboard aircraft systems. The Airborne Research Integrated Experiment System, or ARES, uses experimental systems that detect turbulence minutes before an aircraft encounters it. This new system may allow pilots to avoid severe turbulence, making flying safer. I spoke with Neil O'Connor in the Crew Systems Branch at NASA Langley Research Center to find out more.
You can think of turbulence as any phenomenon in the atmosphere that's going to upset the airplane. Changes in wind that can cause the airplane to be disrupted from its normal flight. You can also get turbulence whenever you have wind rushing over the top of a mountain. The leeward side of a mountain can be very turbulent. You can also get turbulence wherever the jet stream is active. There's a high wind speed in the region of the jet stream, but slower right nearby. Thunderstorms can cause turbulence. Everyone knows right nearby the storm, but sometimes even 50 or 100 miles away in the clear air, you can get turbulence from a thunderstorm.
So Neil, how are pilots avoiding severe turbulence now?
For the most part, pilots have several simple options. They listen to the radio to hear if other pilots have already encountered turbulence in that area. So that means somebody's already been hit. They can also look at their onboard radar and try to, based on their experience, can extrapolate what they think might be, but it's not really foolproof. And they can also get a general forecast from the government sources or from their own airline.
Okay, we got some turbulence now. We're about 3 miles short.
Though seldom damaging to modern aircraft, turbulence is the leading cause of in-flight injuries among passengers and flight crews. On average, 58 injuries aboard aircraft are reported each year. 98% of these injuries occur when unsuspecting passengers or crew are unbuckled or out of their seats when an aircraft encounters turbulence. Currently, there are no instruments on board aircraft to detect turbulence before a plane encounters it. NASA researchers hope to change this by incorporating new turbulence radar systems within existing onboard weather radars. With this new radar system in place, researchers hope to provide pilots with enough warning to either avoid the turbulent area or at least give passengers and flight attendants enough time to return to their seats and buckle up.
The radar system itself will just be a software upgrade to the existing wind shear radar that's already on board the airplanes. The beauty of that, of course, is that since it's just an upgrade to an already certified piece of hardware, it should be relatively inexpensive because you're just incrementally changing what's out there already.
So Neil, tell me how exactly this new system is going to work.
The way it'll work for the pilot is that he'll flip a switch that's labeled turbulence, and then he'll have the new software running. It'll be running mostly at cruise altitudes where the pilots typically allow people to move around the cabin. It's not a problem when you're climbing or descending because everyone's already strapped in. So if you have a turbulence encounter there, it's not a big issue because everyone's already buckled in. But we want to help make a difference at altitude when you don't always know there's going to be turbulence out there. And this new product will be able to increase the capability of the system and increase the pilot's confidence in the accuracy of the system, leading to a better and safer environment.
Besides radar, is there any other kind of research with turbulence?
Doing other research, both onboard and otherwise. The onboard system is called the In Situ Turbulence Warning System, and that's a system that uses accelerometers on the airplane to measure what the airplane feels at a given moment. That'll be transmitted automatically to all other airplanes in the general area, along with the location. And a receiving airplane will take that data and adapt it to its own size and class of airplane, and then assess whether or not it's a threat to that airplane. And if it's a threat, then it'll tell the pilot. Another way of enhancing what we have now is improving our forecast capability. And that gets into modeling of the weather and other phenomena of the atmosphere to better understand what the potential is for turbulence.
So Neil, what are your hopes for this project?
Well, the ultimate goal, of course, is to increase the safety and reduce injuries caused by turbulence on the airplane. Right now, it's very easy to prevent injuries when you know you're going to have turbulence. The pilot says, hey, we got to buckle up for a few minutes. Everyone does it, no one gets hurt. But you don't always know the turbulence is coming. So sometimes if you don't know, people are walking around and the plane gets a lurch, someone's going to get hurt. And it happens now. So we know we can make a difference by improving the product.
That's it for this edition of NASA's Destination Tomorrow. Thanks for joining us. I'm Steele McGonigal.
And I'm Kara O'Brien. For all of us at NASA, we'll see you next time.